So welcome everybody to July's technical training meeting. We appreciate you guys joining us. If anybody is not available to join us, I am recording it. We'll send a link out later. But I guess we'll just go ahead and get into this. If I can remember how to run my slides. Okay, so in today's meeting, we're going to go over just where we ended up for the year on production. And then Dalton is going to do some field guide training. And then I'm going to cover some code training on foam plastics in residential buildings. So that's the goal for today. Before we get into any of that, is anybody aware of any trainings or anything that would be good information for this whole group that they'd like to share? All right. So here's the production numbers for the end of the year. Just the same charts that I've been using the whole year. On the left-hand side, this chart shows what our actual goal was, because we each had a monthly goal, or each agency had a monthly goal, and if you added them all up, the blue stuff just shows what that actual monthly goal was, and then the red stuff shows what the actual monthly production was. As you can see, like for the month of June, the production for the whole program was 50 units, and the goal would have been somewhere 37. So anyway, so that just kind of shows you, hopefully something like this will be helpful as you're planning next year, that you can kind of see, you know, this is the whole program, but if you were to look back and chart what your agency actually did, it might help you identify, you know, when you really got slammed by crisis and had to put some of the weatherization stuff on the back burner and stuff. So anyway, that's all that is. On the right-hand side, this was our total, just kind of a running total for every month, showing what our total goal was and what we actually accomplished. We did fall short of the required number of units for the year. As you can see, we fell, I didn't do the math, looks like we were somewhere around 60 or 70 units short. And then on the next screen, I just wanted to thank these three agencies who met contract. Bear River Association of Government, Housing Authority Utah County, and 5 County, those three agencies turned in either the exact number that they were required, or I think a couple of them went over a little bit. So thank you guys very much for meeting contract. The other agencies, for the most part, didn't fall too short, but when you add it all up, we ended up below where we needed to be. We will be looking to you guys over the next year for your suggestions and advice on how to meet contract. And we hope that you'll also talk within your agencies and you know, either maintain what you're doing where you did meet contract, or figure out ways to ensure that next year that you do meet contract. And if we can help in any way through training, or if Brad can assist in any way, reach out to us and let us know what we can do. But with all of that, really thank you guys for all that you do. Thank you for your hard work. It's been a good year. It's been an awesome year. I feel like we've accomplished a lot. We've done a lot of training. I feel like we've become a better program this year. So please keep it up, and we will continue to ask more of you next year. So any questions or comments about our production or what we've accomplished this year? All right. Okay, we'll go to the field guide training with Dalton. Dalton, I do have a couple of those slides we talked about yesterday, but I can turn the I can turn the screen over to you for until you need them.
Okay.
If you're ready for that. And if I can figure out how to do it. All right, I think you have control.
All right. Can everybody see the field guide?
I can.
Yes, I can see it.
All right. So I wanted to talk about unbalanced airflow or an unbalanced system. So it kind of affects a lot of things in a home, so it's a pretty good topic that everybody should have a good knowledge about. Want everybody to have a good understanding of. Will somebody out there, besides any of the state staff, read the first paragraph right here in just starting at closing interior doors? Is there anybody that would be willing to volunteer?
Greg Kenoshita volunteers.
Okay, Greg.
Greg Kenoshita doesn't have a mic.
Yep.
A likely story. Of course, he had the same story last month, so I kind of believe it.
How about Jesse? Jesse Wake. Will you volunteer?
Can you hear me?
Yep, we can hear you.
Okay. Sorry, I've been trying to place my sound.
Paragraph. So.
Okay. Closing interior doors often separate supply registers from return registers in homes with central returns. A bedroom without a return register and with a closed door restricts a bedroom air from returning to the air handler. This restriction pressurizes bedrooms and depressurizes essential areas near the return registers. These pressures can drive air leakage through the building shell, create moisture problems, and bring pollutants in from crawl spaces, garage, or CAS.
Okay, thanks, Jesse. So we're just talking about how and there's a lot of things that can affect it, but just where you got more supply than return or more return than supply in a home. And I'm gonna play this little video. It's not the most entertaining thing, but it gives us a pretty good description of what we're talking about today. So it's just a 3-minute video here.
We can talk about unbalanced airflow. So here in this diagram, we have a furnace in a basement, and we have 2 supply registers, one in the living room and one in the living room. And then we have 1 return register. The bedroom doesn't have a return register. So that means that we have this door closed here, that this area of the house, because all the air has to return back through this 1 register, is going to be depressurized. And so there's going to be a negative pressure in this room and a relatively positive pressure outdoors. And so we're going to be driving air leakage into the building through the holes that are in the exterior walls of this living room. And the greater the pressure is, the greater the air leakage is. So in this diagram, we're showing what's happening in the bedroom. In the bedroom, we have this door closed. And really, the only way for this air to get back to the air intake is through the door. And if the door is closed, then we've got this pressurized. And again, as we showed over here, we've got this depressurized. So with this, we're driving the heated air out of the building. That's expensive to do. We don't want it to heat it. Really, what we want is for there to be a clear path supply registers, return registers, and sometimes there isn't. And sometimes we have to either put in, more return ducts or cut doors on things that help repair its back. This is unbalanced airflow. We want the airflow to be balanced. We want the air to get back to the air handler. Why is that important? Because we don't want to pressurize the building. So if we had a home and we had 4 or 5 pascal pressure difference between the indoors and the outdoors caused by the air handler, well, that may give us something between 3 and 600 CFM of air exchange whenever the air handler. Well, that's a lot of air to be exchanging with the outdoors. It's expensive. That's why we're concerned about it.
All right, guys. I want to talk about the effects on a home. So what I want you guys to have a discussion about this. What effects does an unbalanced system have on the efficiency of a home? In regards to like the efficiency of a home.
Well, you're not getting heat to where it's supposed to be going.
Yep. You can have some areas that are not getting conditioned like they should be. What else? How else does an unbalanced system affect the efficiency of a home?
Can cause unwanted air leakage in certain areas.
Yep, it exaggerates air leakage. When you start pressurizing or depressurizing rooms, any air leakage that's in those rooms are going to be exaggerated, like he was talking about. When you get the room under like 4 pascals of pressure, you could have quite a bit of an increase in leakage. So it becomes a driving force for leakage. 2, what if you have a bunch of registers or returns that are blocked and covered on a furnace, and that could increase the static pressure, right? On your air handler, which is going to increase or decrease the efficiency of your system. Is there any other effects as far as efficiency goes? Does anybody wants to mention? Okay, so that's some of the reason. That's some of our concerns. The next thing I want to ask you guys is how does an unbalanced system or unbalanced airflow affect the air quality in a home, or how can it?
You pulling contaminants from places like crawl spaces and attics and garages.
Yep. So you can start pulling in different contaminants. Is there any other way it kind of affects the air quality? What about if you have a room that there's no airflow going in or out of? The air can get pretty stale. It can become unhealthy, right?
Stratification. Yep.
Okay. And then how does Jesse kind of already hit on this a little bit, but how does an unbalanced system affect the home's comfort?
Greatly affects it. Causes hot and cold spots.
Yep. If you're going to have hot, cold spots, you're going to have an unhappy client if they've got an unbalanced system. And then this one they don't really talk about in this section, but how does an unbalanced system affect your CAS? Or how can it?
Make it negative or positive pressure.
Yeah. A lot of times it can make it pretty extreme, one way or the other. So having an unbalanced system, I just brought up those 4 things just because it's affecting a lot on a home. It's not, it kind of goes across the board there, as far as the efficiency, the comfort, the air quality, affecting your CAS and the, comfort of the home. So it affects a lot of stuff of how your home functions. So that's why it's so important to us. Let's see. What are the causes for an unbalanced system? What are some of the things you guys see in the field that have contributed to an unbalanced system in a home? Like, what's some things to look for?
Duct leakage.
Yep, duct leakage, big time. What else will cause it?
Block supplies or returns.
I couldn't hear that.
Blocked supplies or returns.
Yep, blocked supplies or returns. That's usually a big cause for it. Is there anything else you guys can think of?
Doors being shut has a big effect on it, especially if the duct system isn't properly designed with returns where they need to be.
Yep, so just like he was showing in that video, if you've got your supply in here and you got the door shut and that air cannot get back into the main body of the house where the return is, you're going to have a problem, usually. And that's kind of what we'll be testing for. So, so those are usually the things: blocked registers, returns, disconnected ductwork, isolated rooms, those kind of things you want to be aware of when you're determining if the system's a balanced system or not. Let's talk about the testing. Will somebody read the next paragraph in these three bulletins?
I'll read it, Dalton.
I was hoping nobody from the state. All right.
The following tests use only the air handler and a digital manometer to evaluate whether the supply air can flow back to the return registers relatively unobstructed. Activate the air handler and close the interior doors. 1. Measure the pressure difference between the home's central living area and the outdoors with a digital manometer. 2. Measure the bedroom's pressure difference with reference to the outdoors. 3. Or you can measure the pressure difference between the central zone and the bedroom. And then there's a little scale down there that shows you kind of where you want to be.
Yep. So if you are measuring the central home with reference to outdoors and the bedroom with reference to outdoors, you add in those pascals, and you don't worry about the negative or the positive, and that's your pressure difference from your room to your central zone. The easiest way, and the way that we did it when I was in the field, is you kick the air handler on, and we would just do this test right here, where you just go from the central zone. You'd be standing in the central zone holding the manometer, and you'd throw the hose under the bedroom door and shut the door and see what the pressure was in that room. And if you're anything above 3 pascals, you want to do something to get the air back to the return. I'll just read this next paragraph. If the difference between the bedroom and the central zone is more than 3 pascals with the air handler operating, pressure relief is desirable. Like TESP, disregard the positive or negative signs and add the absolute values. To estimate the amount of pressure relief needed, slowly open the bedroom door until the pressure difference drops below 1 pascal. Estimate the surface area of that door opening. This is the area of the permanent opening required to provide pressure relief. Pressure relief may include undercutting the door, installing transfer grills, or installing jumper ducts. Matt, this might be where I'll have you pull up. How do I give you back the screen, Matt?
I think I can take it back.
Okay.
All right. And then
We got a few pictures here of
some transfer grills.
some of the solutions. Yep. So say you tested this room and you were at, like 4 or 5 pascals of pressure with the air handler running. If you install just a transfer grill above the door, and these pictures kind of show you how to do that. You just measure it out, cut it out, make sure it's sealed so you're not leaking through the wall cavity. You're not creating more air leakage. And then you install some grills on it, and that allows that air to transfer, and it diffuses so that pressure won't build up. Gives that air a path back, like John was talking in the video. So that's one way, is the transfer grills. Some clients don't like that, and so another good solution is the jumper duct. So you put what would look like a register or something in the ceiling, and you just got to cut it in. And most of you guys know how to do this kind of work, but you cut it in, install it, and then you connect the flex from there into the hallway or to the main body of the house, from the room to the main body of the house. So it essentially does the same thing. You just got to make sure you get it air sealed so you're not creating more air leakage. Do these pictures, do you guys feel these are pretty instructive?
Yep.
Okay. And then the other one that they talked about too is you can undercut the doors. Clients don't really like that a lot, and a lot of times when you do the test of opening the door to see where to get down the pressure to 1 pascal or less, you'll find that you end up having to cut quite a bit off the bottom of the door, depending. So typically you'll probably end up going towards the transfer grill or the jumper duct. But let's see. That's about all I had on that topic. Do you guys have some questions for us, for me? Do you guys understand the testing part of it good enough?
Yes, sir.
All right. Just make sure we're implementing this. And if any of your agencies, if you guys don't feel like you guys are understanding what needs to be done, email me or call me, and I can come out and I can go through this on a house or two with them. So do some on-the-job training.
The only way you guys will learn and pick it up and start to figure it out is if you actually start to take the time to do it out in the field. It's like I always said, we can provide training all day long, and if you walk away and throw all your handouts in the garbage and leave and never do it again, you'll forget it immediately. So, take the time to practice this stuff out in the field. Take the time to practice it at your own house if you need to. That's the only way you're going to learn it and get it.
Yeah, you gotta do this daily. So, and don't hesitate to let me know. If you're feeling weak in it or whatever, I can come out to your guys' agency and go through the testing process. So
what are you calling this on the audit?
That's a great question, and that another auditor actually asked, basically, how do we pay for this? So auditors, Is this an ECM that we can just plug into the audit and just select it from one of the drop-down lists? Or do you have to go about it a different way?
You could possibly tie it to air sealing if you can figure out what the leakage is, calculate it out somehow.
And I think that's right at the heart of the issue, because this is not something we can easily calculate. There isn't a checkbox or a drop down or a screen on the audit that says, hey, you know, you need to do this and here's an SIR for it. Because we can't easily calculate an SIR for this, this one's going to be a non-audited measure. I would recommend that you don't use your air sealing budget for this. Because you can do it as a non-audited measure. I feel like it's a little bit of a stretch to try and tie it to air sealing. But to answer Nate's question and whoever else just asked about it, how do you pay for this? You just run this as a non-audited measure. And so I like Nate's question. He's asked if worst case passes, so our appliances are all venting under worst case conditions, and we're not doing anything to the heating system, how do we pay for this? And I guess that asks another question. If all the appliances are venting under worst case and we're not doing anything to the heating system, what reasons would we want to do any of this stuff? Give me a couple of reasons why we would do this if we're venting right and the heating system's not going to be touched.
This doesn't always tie back to a problem with the CAS. One of the main things of this, like we discussed at first, is comfort issues, efficiency issues, and indoor air quality issues. So yeah, maybe it's not affecting your CAS and all your appliances are venting, but maybe there's a ton of contaminants being pulled into the home from an attic or a crawl space because of an unbalanced system, and we are able to test for that and fix it and solve an indoor air quality problem for the client. Or maybe the bedroom that's always cold and no one can figure it out, and we do the testing and go, hey, I bet if we install a jumper duct or a transfer grill, we can solve that cold bedroom problem. And so, yeah, it's something that doesn't have an SIR, but sometimes it's the right thing to do to fix a problem. And so we can do it as a NAM.
Does that answer the questions? The auditors, you guys feel comfortable if you had to go write this one on an audit today? Would you know what to do and how to justify it? If not, speak up and let's talk about it a little bit more. But I hope it's pretty straightforward, and it really is. All of the reasons that Dalton just listed off, all the reasons that Wade just listed off, the non-audited measure is oftentimes the measure that we go to do the right thing. And so don't forget about it. It's a tool in your tool bag. Use it when it's appropriate, because you really can. You got a master bedroom, and the person that lives there is always cranking the heat up because their bedroom's cold. You could save them a ton of money by fixing this little problem. Or if you got a really positive bathroom, you're driving moisture into the walls every time they go in there and close the door and turn on their shower, and then their furnace kicks on. You're pushing moisture right into the building cavities. So anyway, awesome. Thanks, Dalton.
Hey, Matt.
Yeah, go ahead.
Yep.
I just want to point something out. It can kind of be fooled on the numbers. So if you have a really leaky zone, and then you go do this other measurement, and it's like a 0, it could be misconstrued. So keep that in mind when you're doing it too.
Because that could be that the room's not able to pressurize because it's so leaky to the outdoors.
Correct.
Got it. And that's where I think your bedroom with reference to the outdoors can help identify, what your pressure is based to the outside also, not just to the central part of the house. But that is a good point, Jesse.
It's a great point, Jesse, and it just further emphasizes the whole idea that if you don't do this, if you don't go out and practice it, if you don't find the anomalies, you're never going to get it. That's what I tell everyone. The only way you're going to learn this is to do it, and you're going to discover those weird things that you're going to run into out there, and you will, trust me, you're going to run into weird readings, and you just got to go back to your foundational basic science principles and start figuring it out. And once you do it enough times, you'll get it, and you'll become really good at it, but that's what it takes, is actually doing this stuff.
So Dalton, correct me if I'm wrong. This looks just like room-to-room zonals, but when I'm doing my room-to-room zonals, I'm using the blower door as the driving force. And if I'm doing this test, I shut off my blower door, and now I'm using the air handler as the driving force.
Yeah, you're only using the air handler because you're seeing what that system, if it's balanced in the home or if it's creating unbalanced pressures throughout the home. So. Yep, it's just the air handler.
So in Jesse's example, when I ran my blower door, I found that bedroom was really connected to the outside. It's really, really leaky. And then when I shut that off and I turned on the air handler, I'm finding that I don't really have a major pressure difference from the outside to the inside. But
that's probably because it's so leaky. Yep.
Yeah, it could still be, because it's so connected to the outside, it could still be an unbalanced system.
Yep, absolutely.
And to further expand on that, if that extremely leaky bedroom, when you shut that bedroom door and that room is becoming pressurized and all that air is leaking to the outside, although you might not see a big reading pressure difference from the room to the main body of the house, but if all that air is leaking to the outdoors, you've just created a very large exhaust fan by closing that bedroom door. And so now that air leaking out of that bedroom could cause depressurization in other parts of the house, like, for example, in your calves, perhaps.
Yep.
Like, remember the job with the supply register right under the window swamp cooler?
Yep. Yep. That gave us an extreme negative pressure in our calves.
Extreme negative pressure in our calves because all that air being blown into the bedroom was going right to the outdoors, so it's essentially an exhaust fan. And again, the way you're going to figure this out, guys, and find these things is to take the time to do it in the field.
Thank you. Any other comments on this one? Oh, I'm just looking at, Greg had a question I got to read through real quick. He's wondering if you could tie this measure to an ECM motor since it could affect the static pressure. And you could make it incidental to the installation of an ECM motor, so you could do it as an IRM if you wanted to.
And Matt, typically, so if it is creating static pressure, a lot of times that's like where they've got the furniture or something blocking the registers. You're probably not going to be putting in transfer grills and stuff at that point. I don't think, but it could, I guess, still with the pressures building up in the room.
The biggest thing with your static pressure, Greg, would be blocked or plugged registers and grills. So that'd really be a matter of unblocking them or, something like that.
Client education.
Just the unbalance itself isn't necessarily going to contribute to static pressure problems because the air is still coming out of the ductwork. But once you start restricting the ability of the air to get out of the ductwork, so say like all the floor registers are smashed up or closed or covered with whatever, then you'll start to see static pressure problems under those circumstances.
Okay. So hopefully that answered that. Anybody have any other comments or want to talk about this anymore? All right. Again, thanks, Dalton, for this. And this is what we'd like to try to do. We're gonna spend the first 15 minutes or so going through something in the field guide. So if there are other people, other members of your staff or other teammates that would benefit from this, please invite them to join us. Let's move on to. Oh, sorry. Go ahead, Dalton.
Just one more thing, and also if you guys would like to review a specific topic in the field guide, let me or Matt Turner know.
Yeah.
So we can arrange that.
Perfect.
So.
Okay. I wanted to talk about foam plastics for a few minutes. I feel like we've got a pretty good handle on this, but I had two different things come up just in the last 4 or 5 months. And it caused me to go back and read through the code on foam plastics and what the building code was. And so just thought it would be valuable to review that with everybody. The two things that came up, while I was out monitoring, I noticed that one agency, they were using foam plastic, so either some one part or some two part to seal their pin and drape, like around the window, and to like basically fasten it to the wall in some areas. And as we go through this, I want you to think about why that would not be allowed per the building code. I really liked the agency's ingenuity there because it looked like a very durable way to fasten it, but because of some of the other stuff in the building code, it's something we should not be doing. And then there was an agency that had been trying to find a solution for a thermal barrier, and they found some intumescent paint. But as we looked further into it, that didn't meet the requirements of the thermal barrier, which we'll talk about as well. But again, thank you guys for thinking outside the box and trying to find new solutions. Please don't stop doing that. I really want to encourage that. And then every time we do that, we just want to take a good look at it and make sure that it still meets building code and things like that. So anyway, those were the two things that caused me to go back and read the code. And so I just want to take some time and actually go through the code here. I am going to be reading from the code, but I've tried to break it up into little pieces. We're not going to read every detail of it, but I feel like there's a couple of sections here that are that pertain to what we face every day. So this is the International Residential Building Code. And it's the 2018 code that I'm reading from. And I'm in chapter 3, and it's chapter 3.16 or section 316. And that's the section on foam plastics. So if you're looking for it, if you'll just do a search online, you can find the code, and there's free public access to it. With the public access, you just can't cut and paste stuff to put it into a report or anything like that, but you've got free access to this anytime you need it. Anyway, so section R316 is all about foam plastics. You can find information in the commercial code as well. The commercial code gets way more detailed. I feel like they've done a really good job of boiling this down to keep it pretty concise for the residential side of things. So the first thing, just the general provisions, it just says the provisions of this section shall govern the materials, design, application, construction, and installation of foam plastic materials. So that's all of the stuff that we're putting on a house that's made out of foam. And there's some better definition where it's basically plastic that's mixed with an accelerant to cause it to turn into foam. They use a lot smarter words than that, but that's pretty much how they define foam. So we're seeing foam in sheet goods, and we're using the 1-part and 2-part sprays. And so I think that's really the stuff we need to be aware of and think about how we're using it. So section number 2 just basically says all of the foam that you're putting on a building, it has to have labels on its packaging. to identify it, and it has to be sufficient to determine what the end use will be and whether it'll comply with the requirements of the code. Section 3, this is what's kind of important about foam plastics. So Section 3 talks about surface burning characteristics. Foam plastics are flammable, and that is why we have to be careful. They are extremely flammable while you're spraying them. So if you're using a 1-part or a 2-part, you've got to worry about the flammability while you're installing it. And then once they're installed, they're also very flammable. And same thing with the sheet goods. When the sheet goods are installed, they're very flammable. So the building code has some requirements to govern that and to help protect people. As I was preparing for this, I came across some stuff they just had a whole bunch of commercial fires. I don't know if you guys remember the fire, the band Great White. There was a fire in a little club, and that was caused not necessarily by foam plastics, but by some non-compliance to building code issues. There was a fire in a club in Brazil back in like 2013, and that was caused because they didn't have enough exits, but they also, when the band used some pyrotechnics, the foam, they had some of that eggshell foam attached to the wall for acoustics, and that is what basically accelerated the fire, and it ended up killing like 250 people. So it's pretty important to follow all of the building codes, and all of those become a factor. Like there wasn't proper exits, and they had some foam hanging on the wall that should have been covered by a thermal barrier. So anyway, that's the main thing we're worried about. We're worried about how quickly will the house burn down if we're putting foam in it, and if we are, how much smoke's going to come off of that foam and cause people to pass out before they can get out of the house. So Section 3 is about the surface burning characteristics, and it says unless otherwise allowed in Section 316, which we're reading 316, and we're going to get to Section 5 in a minute. So it says unless it's allowed in Section 5, foam plastic or foam plastic cores used as a component in manufactured assemblies used in building construction shall have a flame spread index of not more than 75 and shall have a smoke development index of not more than 450 when tested in the maximum thickness and density intended for use in accordance with ASTM E84 and UL 723. I don't have time or the knowledge to get into the details of what these are today, but you can do your own Google search on those if you'd like. And then it says loose fill type foam plastic insulation shall be tested basically as board stock and have the same flame spread and smoke index. But basically they burn it in a lab and they test how quickly the flame spreads, and they test the smoke development, and they give it a rating. And all of the stuff that we're putting in homes, it has to be less than 75 on the smoke or on the flame spread and less than 450 on the smoke index. So if you're ever wondering if you've got a product and wondering if you can install it in a home, that's kind of the first test or the first measurement. So we've read sections 1, 2, and 3. Section 4 talks about a thermal barrier. And so it says, unless otherwise allowed in Section 5, which we're going to get to in a minute, foam plastic shall be separated from the interior of a building by an approved thermal barrier of not less than 1/2 inch of gypsum wallboard, or 23/30 seconds, which is just shy of 3/4 of an inch, of wood structural panel, or a material that's tested in accordance with and meets the acceptance criteria of both the temperature transmission fire test and the integrity fire test of NFPA, which is National Fire Prevention Association 275. So 275 is their standard method for fire tests for the evaluation of thermal barriers. So basically, there's some exceptions in 5, but it's basically saying, in general, if we're putting foam plastics inside of a house, then they have to be covered by a thermal barrier. What kind of thermal barriers can we use? What are the allowable thermal barriers here?
Sheetrock.
Yeah, sheetrock, 3/4 inch of structural panel, so that's like plywood or OSB, or something that has been tested in accordance with NFPA 275. So for us, sheetrock, 3/4 inch of wood, basically, right? Now there's some exceptions for attics and, crawl spaces, which we'll go through here in a second. So we've read sections 1 through 4. I'm going to skip to section 6 really quickly because as we go through section 5, it keeps talking about section 6. So section 6 says that if it doesn't meet the criteria in section 5, then you can also get specific approval. Basically, you could pay and have it lab tested and make sure that it meets this other standard, and then it would be okay. So section 6, it's talking specifically about the foam now. We're not talking about thermal barriers. So if you had some foam and you wanted to install it in a house and it didn't meet it doesn't meet that ASTM E84 for the flame spread and the smoke development, then they have this other testing method, which is NFPA 286, and you could basically have it tested and using the actual intended assembly, and you could get approval that way. So if you ever have somebody coming to you saying, hey, we've got this newfangled product and it's magic and it does all these wonderful things, and you can go ahead and install it in all your homes, as long as they have gone ahead and paid and gotten this NFPA approval for the product, then it would meet the specific approval. So if it doesn't, then you can't use it, basically. So that's really all I was talking about when we refer to section 6 here in a second. So now let me go back to section 5. So section 5 says, the following requirements shall apply to these uses of foam plastic unless specifically approved in accordance with section 6 or by other sections of the code or the requirements of section 2 through 4, which we already read. So basically saying you got to follow these things unless you have that special approval in section 6. And you'll notice that I'm going to read section 5.3 and 5.4 and then 5.11. So there's more to the code that we're not getting into right here. But if you're interested in this, take the time to read through the entire section of the building code because there's a little more to it. But basically, section 5.3 talks about attics, and this says the thermal barrier specified in section 4 is not required where all of the following apply. So section 4 said either drywall or 3/4 inch of wood. And it says in an attic you don't have to do that as long as you can meet the requirements of 1 through 3. So number 1 is that the attic is required as per the residential code section 807.1, the attic access. Basically the attic access is going to be a certain size so you can enter and exit the attic, and it's also going to have drywall or 3/4 inch of wood as the opening. So it's basically going to have a thermal barrier at the attic access. Number 2, the space is entered only for the purposes of repairs or maintenance. So what are some other reasons that people would enter this space that are not for repairs or for maintenance?
Storage.
Yeah, our clients love to store stuff in their attics and their crawl spaces. So if they are storing stuff in their crawl space or their attic, then we have not met number 2, and therefore the thermal barrier, which is required in section 4, is now required. So if you went into an attic and you wanted to install a bunch of foam, but they have stuff that they're storing up there, you can't put the foam up unless you get the client to commit to stop doing that. And then number 3, it says that the foam plastic insulation, so we have to have an attic access. We're only entering the area for repairs or maintenance. And then number 3, the foam plastic insulation has been tested in accordance with section 6, or the foam plastic insulation is protected against ignition using one of the following ignition barriers. So in section 4, we talked about thermal barriers, which is 1/2 inch of drywall or 3/4 inch of wood. Here we're talking about ignition barriers. Basically the same idea, same principle, but here they have a different list of things you can use. So in an attic, you can use 1.5 inches of mineral fiber insulation, 1/4 inch of wood structural paneling, 3/8 of an inch of particle board, 1/4 inch of hardboard, 3/8 of an inch of gypsum board, or 0.016 inch thick corrosion resistant steel, or, this is our favorite, this is the one that we use the most, 1.5 inches of cellulose insulation, or 1/4 inch of fiber cement board. So if we went up into an attic and we were only, the client, it's only going to get entered for repairs and maintenance, and we have a good attic access, and we have a big bypass, and we've decided to air seal some of that bypass with some rigid foam board, then what do we need to do as far as our ignition barrier on top of that and underneath that board? What are our options? What do we got to put on top of the foam board when we're done installing it? We got to put an ignition barrier on there, right? And what's the most likely thing that we're going to put on top of here?
Attic insulation.
Yeah, we're gonna either put on some cellulose or some mineral fiber. Probably some cellulose. What about underneath it? How do we meet the requirements of the ignition barrier on the side that's kind of inside the chase that we just air sealed? Are we meeting this section of the code on that side of the chase? Do we have a 1/2 inch of drywall or 3/4 of an inch of wood inside there? It doesn't say they have to be in alignment. So if the chase is made up of 1/2 inch drywall and all of the wood framing members and structural members are at least 3/4 of an inch thick, then my interpretation is that we meet the code. So I think we're okay if we put the rigid board down and we put at least 1.5 inches of insulation on top of it. My reading of this is that we're meeting that code. So what you've been doing works great. So that's attics. The next one is crawl spaces, and crawl spaces is pretty much the same as an attic.
Hey, Matt.
Go ahead.
Before you moved on from attic, so this is going to apply with the attic accesses too, because they use rigid foam to insulate the attic accesses a lot of times. So they need to be, do they need to cover all 3 sides of the foam
So
with an ignition barrier?
that's a good question.
Because a lot of the agencies are using, where they'll pile up like three layers of the foam board
Yeah.
on the attic access, on the inside of the attic.
That's a
the one side you have, you know, the gypsum or the 3/4 plywood, but on the inside of the attic, do they need to build a 3-sided box to cover the foam within an ignition barrier, which could be like the 1/4-inch hardy board or something, or
yeah.
is that correct?
A
I just
strict
want to be clear on it.
a strict reading of this suggests that, yeah, you would have to do that.
Okay.
But
Just so everybody
you
knows.
guys know how the code stuff goes, you know. It's kind of up to the interpretation of your local code enforcement. But yeah, that's a good question. See,
I see. I mean, it works good for insulating those attic hatches, and it stays on, and so it's not a, you know, it's not a problem. Kind of like when you use the bats or something like that, they end up falling away.
Yep.
It's a good way that they're insulating them, and it gives that hatch some weight to it and stuff. But I just want to be clear if they have to start putting an ignition barrier around that, so we know.
Yeah. I will go and read section 807 and see if there's any information in there that will help answer that. And if there is, I'll send that out to this group for any clarification. But if not, I'll be looking to you guys if you know, as far as what you guys run into. If you guys can help find that answer, that would be great. So, thanks, Dalton. Thanks, Troublemaker. No.
Yep.
Okay, crawl spaces. Same thing as the attic. Crawl space access is required per section. It's a different section, but that's the section that specifies what the crawl space access has to look like and how it functions. Entry is made only for the purposes of repair or maintenance. And then the foam plastic has either been tested according to Section 6 or it's protected against ignition using one of the following ignition barrier materials. And you'll notice this has the exact same list. This has 3.1 through 6. I'm going to go back a slide. This had 3.1 through 6 plus 7 and 8. 7 and 8 were cellulose and fiber cement. In the crawl space, it just has, it just has 1 through 6. So it's either mineral fiber insulation, wood structural panel, particle board, hardboard, gypsum board, or some metal. So so this is saying that if we, I guess, so the question is, in this picture, is this okay that they have this foam on the walls of the crawl space?
Yes.
So let's pretend they have the crawl space access in place and they've met number 2, that entry is made only for the purpose of repair or maintenance. How do they meet number 3 in this picture?
It's got the rating.
It's got what rating?
The ASTM E84.
Oh, and this answer, I think, answers what Dalton just pointed out. So we have to protect this foam plastic has to be protected against ignition using one of these following ignition barriers. And I think the ignition barrier in this case is going to be our floor. So if we have a wood structural panel or particle board or hardboard that's at least that thick, then it's protected. And I think that the attic access, the drywall on the attic access acts as that ignition barrier as well. Because my understanding and the interpretation I've gotten from a handful of others is that we're allowed to do this kind of stuff in a crawl space and in an attic so long as we're not going in there except for repairs and maintenance, and it's because we have that ignition barrier in place. So.
Okay, so it's just got to be between the living space and
Yes.
that area. Okay.
So in this case, we're meeting all those requirements, and the big one there is that we're only entering for repairs or maintenance. There's nothing stored in this space. So, any questions on the crawls and the attics before I move on to the one exception that we want to address? And then, yeah, I think I got about 5 more minutes of stuff, and then we'll end. So I apologize, we're going a little over today. So sill plates and headers. So we just read section 5. So point 3, point 4, and now I'm jumping to point 11. So sill plates and headers. It says foam plastic shall be permitted to be spray applied to sill plates and headers or installed in the perimeter joist space without the thermal barrier specified in section 4, subject to all of the following. So it's okay to spray up in here or on the sill plate or on a header, as long as the thickness of the foam plastic is no more than 3 1/4 inches. The density of the foam plastic shall be in the range of 0.5 to 0.2 pounds per cubic foot. And the foam plastic shall have a flame spread index of 25 or less and an accompanying smoke development index of 450. So in general, they said it's okay, we can go up to a flame spread of 75, but here, whatever we're spraying on that rim can't have a flame spread index above 25. So does anybody know if the 2-part foam that they're spraying on their rim, if the flame spread index is less than 25? Has anybody checked that before to see if that's the case? And it's tested in accordance to that ASTM E84 and the UL 723. So I just went and grabbed the Dow froth pack. You guys need to check this for the product that you're using. The Dow froth pack shows on its data sheets that they lab tested this and found a flame spread and the smoke development of flame spread of less than 25 and the smoke development of less than 450. So do they meet the requirements? Can we use the Dow froth pack to spray up here?
Yep.
Yeah, it's got the flame spread index of 25 or less and the smoke development of 450 or less. So why are they allowing us to do foam right here inside of the building envelope without an ignition barrier or without a thermal barrier? Any ideas? I've made my own assumption about it. Just wondering if anybody has any thoughts on it. So basically, again, it comes back to we're protecting the occupants from being killed in a fire, right? And I think at some point somebody was able to make an argument to say, however big the perimeter is on whatever house, this amount of foam should be small enough to where it's not going to cause a major problem. And so the building, the code commission decided that it would be okay to do that. And that's why they've attached this thickness provision to it. Like, if we get much thicker than 3 inches, then we might we might start to get into the area where we're adding enough of this flammable material that it could cause a problem. But if we'll keep it less than 3 inches, and we know that the flame spread is low, then we should be pretty safe here. So now there is one thing to point out. On the Dow froth pack, they tested this at 4 inches wide and 2 inches thick. So if they only tested this at 2 inches thick, can you install 3 inches on the rim? My response is probably not, because it has to be tested for the flame spread and the smoke index in accordance with these tests. And as I've dug into those tests, they basically require that you're testing the assembly at the thickness that it will be used. So take a close look at the products that you're using and make sure you're installing them within the manufacturer's specifications. I didn't get time to dig into it any deeper, but I wouldn't be surprised to find this manufacturer might actually say don't spray it on any thicker than 2 inches. But you'll really need to dig into that on whatever products you're using. So in summary, if you're spraying foam inside the building envelope, what do we have to remember? It's got to be separated from the building envelope by a thermal barrier, which is going to be either drywall or 3/4 inch of wood. This is the only area inside the building envelope that you're allowed to spray foam. If it's outside the building envelope, an attic or a crawl space, you can put foam in there, but those areas can only be entered for maintenance or repair, and they have to be separated from the building envelope by one of those ignition barriers that are listed there, or an approved ignition barrier based on one of those testing methods. So that's it on the code stuff. There's a lot more to it, but that's all I wanted to talk about. Does anybody have any questions or anything we feel like didn't get covered or you're still wondering about? All right, it's awfully quiet. Hopefully you can still hear me, and hopefully this was helpful. Thank you guys for participating and for joining us today. And let's go ahead and end there. You guys have a great day.
All right, thanks, Matt.